what do I want you to walk away with today? So we'll just briefly go over kind of how we've come to think about LLMs, including some advanced LLM capabilities, and then we'll engage in a highly speculative exercise as to what the next generation of AI assistants should look like in the spirit of Gen AI. Okay, so a bit of a review for everybody here. It's June 2020. OpenAI just released their GPT-3 API, and everybody's trying to get their sentences completed. So here I am asking it to analogize a chicken and a turkey, and it says the same relationship with an iPhone and a flip phone. Turkeys are very advanced and highly desirable in modern society. So, yeah, just highly opinionated autocomplete at the time. And then there was chat, right? Things really started to get interesting. You could now give it a message and interact in really interesting ways with the training data. On the left is your standard Stack Overflow use case that I've definitely Googled like more times than I should have. But on the right, there's a nice like stylized explain the Node.js programming language in the style of a 90s rap song, right? And that does a pretty good job there. What do I know about 90s rap? But okay, gimmicks aside, like why is this better than a Google search, right? It turns out that you can actually give it some information in the context, and it will, use this reasoning ability is learned from being trained on text to answer the question, right? So, for example, on the left here, I'm giving it a Git ref log, and I'm asking it something like, how do I save myself for this commit tomorrow? And it's trying to help me out. And on the right, somebody charged me with making a meal. Gemini over there is doing its best, right? So this is how this is where you start seeing the productivity gains, right? This is how you become a 10x engineer. And this also is where retrieval augmented generation comes from, right? And that's a whole universe that we're not going to talk about today. And we learned pretty soon that you can actually induce patterns of reasoning, very specific patterns of reasoning, and these actually improve the output of LLMs, right? So, for example, you can give examples of the very question that you're asking an LLM, and it will extrapolate and give you a better response. And there's some artifacts of training some LLMs, where if you just say, let's think step by step, they'll actually go ahead and, with no examples, just generate a step-by-step explanation of what they're thinking and the output, right? And, how far can you really take this, right? Turns out it can get really wild. Everybody's heard of chain of thought, probably, where it's like a linear sequence of steps that the model is able to generate. But you can also prompt it to generate multiple independent chains and then just pick the best one. And you can tell it, okay, somewhere in the middle, backtrack, abandon your chain of thought, backtrack, generate a new thought, and then you get this like branching tree of thought structure, right? And finally, you can generalize that to the max by asking it to merge thoughts and refine thoughts, and yeah. So there's all these computations you can do in just text input space, right? But beyond just single LLM calls, in order to get that really powerful canonical conversational experience, you have to chain them together. So you have to take the output of one of those crazy graph of thoughts and then put it in the input context of another LLM call. And that gives you the ability to like ask follow-up questions and refine your outputs from previous LLM calls. But you can't just do stuff with a bunch of thoughts, right? Sometimes you need to take an action, call a function. It turns out that just by virtue of optimal next token prediction, you can choose the best action from a sequence or a set of options, essentially, right? And a common pattern for this is the react pattern. And this is just an interleaving of that chain of thought with some actions and the observations for those actions. And this is a super common pattern. It's now, with a strong enough model, you can get relatively capable agents, and it forms the baseline for many agent pattern research papers. So once you start calling functions, you need very well-formatted arguments, right? And this is, one of the most interesting parts of prompt engineering is where you're trying to get a model to output well-formed data. And yeah, here's an example of the kind of stages of grief that you go through as a prompt engineer. You think you can just tell it to output JSON, then you try to tip it $20, and the last one there is my favorite, just begging the model. But pretty soon, OpenAI fine-tuned their model to allow you to just output JSON. That's what we now know as function calling. And a lot of the other model providers also followed suit there. So we thought we could leave this behind. Anyway, here's an example of me giving this receipt to GPT-4, and I ask it to tally the items on the receipt and get me the average price. And it decides to write some code, execute the code in a stateful Jupyter notebook, and it even compares some of the output that it gets from executing that code with what it is able to perceive directly from perceiving the image, because it has some basic amount of multimodal reasoning, right? Really amazing, just a combination of all the stuff we've discussed so far. But is that it? Like, are we there? Can we do everything? Is this AGI? Probably not. There's a paper out of Meta called Gaia, and what they introduce is this benchmark for general AI assistants. And something interesting that you can see about this benchmark, if you look at that plot on the right, is that humans, even the average human, just is killing GPT-4 with plugins, right? So Gaia has actually 3 levels of tasks, and they range from just a single web search to indefinitely long sequences of like function calls and multimodal questions, like look at this, this can of beans and get me the number of calories or something like that, right? And yeah, so even our best models equipped with like very curated tools don't even come close to just an average human on these level 3 tasks. So what exactly is missing? So what I think, and this is this is where we're speculating at this point. What I think general AI assistants need is the ability to really attend to and pursue long-term plans and goals. They need long-term memory, of course, to learn from their mistakes, develop skills, and critically, like define principles, extract insights, and save those to be used for later tasks. And yeah, they're going to be great at not only using existing tools, but they need to build and actually use new tools. They need to start applying these things to build tools, right? That's really what the target for a general AI assistant is. Okay, so let's break each of those down. What's planning? One way you can look at planning is, given a task, can you break it down into some subtasks? Can you create a DAG? And can you execute that DAG and kind of recover from errors and things like that? And there's this paper called LLM Compiler where they demonstrate this, and they see a big latency speed up over React and other agent patterns. And critical here is you have to be able to, in the execution of a plan, you end up with some new information. You have to be able to replan, and you need to be able to delegate, right? Super critical to any long-term goal, like, for example, research, right? You need to be able to keep the general context really focused on your main goal and be able to delegate like these side missions to your lackeys. In GPT Researcher, there's like a planner agent that comes up with the main research questions. The executor agents go and they do the actual research, and then there's a reporter agent that synthesizes everything into a report that the human can see. So, from that schematic, you can see this is just a generalization of that previous plot, but now each action can be an agent itself, right? And of course, you need long-term memory. But why do you need long-term memory, right? It's not just a text dump. What you're doing is you're trying to compress things you've learned, right? You're trying to build a model without necessarily tuning weights, right? There's this paper out of, I think, Tsinghua University called Expel, and it's showing that, okay, language models are actually experiential learners too. You can, in this particular paper, they alternate between an experience gathering phase and a insight extraction phase. And it's cool because they give that model the ability to record not only its current state, but then add and subtract rules, like principles that it's defining and keeping track of and using for future tasks. And finally, something that merged kind of all of the previous things together, long-term memory planning, and really built on top of that is this paper out of NVIDIA, this project out of NVIDIA called Voyager, right? And what I have there is not a quote from Voyager, it's actually its system prompt, but I just thought it was really, really interesting. And the novel contributions in Voyager are that it actually builds this dynamic skill library, right? So it starts without skills, without tools, and then it kind of self-suggests, oh, what should I try to do? If you've ever played Minecraft, which is the main application of Voyager, you might know that you can't really do anything without crafting a crafting table. So you have to mine some wood, make a crafting table, and then you can make stone pickaxes and other things. So it starts to do this. And the way that it does this is, so they've actually hooked it up to a Minecraft simulator, Mine Dojo, Mindflayer, and it writes code it writes code as like an attempted skill, right? And that simulator or environment is able to take this code and execute it and generate some feedback. Okay, did you do what you did? Did you do what you want to do, right? Or did you run into an error? Does the code not compile? And it does this iteratively until it gets to the place where it wants to save the skill. And then it generates a description using GPT-3 and then embeds it so that it can retrieve it later based on a similar situation, right? So this is that dynamic skill library, and you can see that it kind of forms this dynamic of like learning skills that you decide you need, right? So this is an example. I think the biggest insight from Voyager is this idea that you can use a simulator as a source of near infinite data that you can use to adapt LLM agents without actually tuning their model weights, right? And I think that no matter how powerful your models, you're going to have to adapt them at the agent level. There's this framework out of you might have heard of AutoGen out of Microsoft, and some of the people from that framework also came up with this idea of agent optimizer, where they analogize model training and agent training, where your model weights are actually, they should be your like tools and prompts and other things that you use. So similar to the way you train your model, you should also be optimizing your agent at the tool and prompt level. Okay, so the big question is like, okay, can I even do this? Isn't this like painfully slow with LLMs, right? And the fact is the constraints are lifting. Like when GPT-3 came out, we had a 4,000 token context window, and then if you put something in the middle of it, filling up all the context, you wouldn't even recall it, right? It would have really poor recall. But now we have like 2 million or 200,000 token context windows in production models, and they have uniform near perfect recall throughout that context window, right? So, and similar things are happening in the inference area where you're able to serve like a 70 billion parameter model at 200 tokens per second, right? That's like 75 words a second. It's way more than a human can just read, right? And that makes sense because humans aren't the ones that are consuming most of the tokens that LLMs are producing, right? So yeah, I mean, what does this all really mean for you, right? So we're trying to move towards this era of general AI assistance, and that means that you need to have a strong RAG story. That's something I haven't talked about here. But you also need to use the frameworks instead of like trying to directly prompt your model. And this will allow you to really pick up the, from the bottom advancements that you're getting from these foundation models, right? Critically target an agent architecture that supports the three things that I talked about, like planning over long horizons, continual learning, and knowledge acquisition, tool creation. Build a gym where you can do this online training using synthetic data or a simulator, so you can optimize those higher level components like tools and parameters. And then throw it all out when GPT-5 comes out. So that's my talk. Thank you, guys.